Hit your hand against the table. It makes a sound. It feels hard. It feels solid. But this is an illusion. If you look deep enough, solidity dissolves. An atom is 99.9999% empty space. To understand the scale, imagine the nucleus of an atom is a marble sitting in the center of a football stadium. The electrons are tiny gnats buzzing in the highest seats of the stands. Everything in between is void. You are not made of matter. You are made of emptiness held together by electric fields. The only reason you don't fall through the floor is because the fields in your shoes are pushing against the fields in the wood. You are hovering forever on a cushion of nothingness. We assume reality is smooth, continuous. Like a painting, you can zoom in forever and seeing more detail. But the universe has a limit. This is the Planck length. It is the smallest possible unit of measurement. If you try to measure anything smaller than this, the laws of physics collapse. Geometry stops making sense. It seems that our reality is pixelated. Just like a video game has a resolution limit, the universe has a minimum grid size. We are living in a simulation that can only render so much detail. So the world is empty, and the world is pixelated, but it gets worse. The world is also shy. This is the double-slit experiment. When we fire particles like electrons through two slits, we expect them to act like bullets. Two lines on the back wall. Instead, they act like water. They create an interference pattern. Many lines. They go through both slits at the same time and collide with themselves. But here is the glitch. If we put a camera next to the slits to watch them, the behavior stops. The electrons go back to acting like solid bullets. The moment we look, reality changes its clothes. The universe knows it is being watched. To understand the glitch, we must redefine what a particle is. We think of an electron as a tiny ball, a hard little sphere, but in the quantum world, this is false. A particle is actually a wave function. It is a cloud of probability. It does not exist in one place. It exists in many places at once with different likelihoods. Think of a crime wave. The crime isn't located at a specific address. It is spread out over the city. Only when the police catch a criminal does the wave become a specific person at a specific location. Until then, it is just a ghost. This ghostliness is protected by a law. Heisenberg's uncertainty principle. Werner Heisenberg discovered a fundamental limit to knowledge. You can know where a particle is, or you can know where it is going. You cannot know both. The more precisely you measure its position, the fuzzier its momentum becomes. This is not because our tools are bad. It is because the universe itself does not have a precise answer. Nature creates a volume to prevent us from seeing the full picture. Erwin Schrödinger tried to show how absurd this was with a thought experiment. He imagined a cat in a box with a radioactive trigger. If an atom decays, the poison is released. If it doesn't, the cat lives. According to quantum mechanics, until you open the box, the atom has both decayed and not decayed. Therefore, the cat is both dead and alive. Schrödinger meant this as a joke. He wanted to show that the theory was ridiculous. But nature does not care about our logic. Mathematically, the cat really is both. We call this state superposition. It is the ability to be in multiple contradictory states at the same time. Imagine a spinning coin. Is it heads or is it tails? While it is spinning, it is a blur of both. It contains the potential for both outcomes. The universe, when unobserved, is a spinning coin. The music of reality is playing every single note on the piano simultaneously. It is a symphony of maybe, but then someone looks. You open the box, you slap the coin, you measure the electron. This causes wave function collapse. The cloud vanishes. The probability reaches 100% in one spot and 0% everywhere else. The universe is forced to make a choice. From the infinite possibilities of the quantum realm, a single reality crystallizes. The act of observation is what forces the universe to decide what is real and what is just a ghost. In our world, if you throw a tennis ball at a wall, it bounces back. It cannot pass through the solid brick. But in the quantum world, the rules are softer. Because a particle is a probability cloud, there is a tiny non-zero chance that the particle is actually on the other side of the wall. Occasionally, it doesn't climb the hill. It simply teleports through it. We call this quantum tunneling. This isn't just magic, it is essential. The sun shines because protons tunnel through each other's repulsion to fuse. Without this glitch, the stars would go out. The universe would be a dark, frozen room. But the strangest phenomenon caused Einstein to lose sleep: quantum entanglement. Two particles can become linked. They share a single mathematical existence. If you separate them by billions of light years, they remain connected. If you measure one, the other reacts. Instantly, faster than light, faster than time. Einstein called it spooky action at a distance. He refused to believe it. He thought there must be a hidden wire connecting them. He was wrong. The connection is fundamental. Space does not separate them. In 2022, the Nobel Prize in Physics confirmed a terrifying truth. The universe is not locally real. Real means objects have definite properties whether you look at them or not. Local means objects can only be influenced by their immediate surroundings. Physics has proven that one or both of these is false. The apple does not have a color until you look at it. The moon might not be there when no one is watching. We are not navigating a solid world. We are navigating a rendered dream. It gets worse. The glitch affects Y in time. This is the quantum eraser experiment. Scientists have shown that actions taken in the present can seemingly affect the past history of a particle. By choosing to measure a particle, now, we force it to have taken a specific path. Then, the arrow of time is not straight. The future reaches back and taps the past on the shoulder. Cause and effect are tangled in a knot we cannot untie. You might think this only happens in cold labs, but life has learned to use the glitch. Birds like the European robin navigate using quantum entanglement in their eyes to see the Earth's magnetic field. Plants use quantum coherence to transport sunlight to their cells with nearly 100% efficiency, far better than any human solar panel. Life is messy, warm, wet, and yet it is a quantum machine. The chaos of biology is built on the ghostliness of physics. This brings us to the deepest crack in the foundation of science: the measurement problem. We know that observing a particle forces it to choose a state. But what counts as an observer? Does it need to be a human with a PhD? Can a camera collapse the wave function? Can a cat? Can a particle of dust? If a tree falls in a forest and no one is there to hear it, in quantum mechanics it might not make a sound. It might remain a cloud of vibrating air probabilities. Does the universe require a conscious mind to make it real? Or is consciousness just another physical interaction? Eugene Wigner pushed this paradox to its breaking point. Imagine I am in a lab. I measure the electron. To me, the wave function collapses. But imagine you are standing outside the lab. To you, I am just a collection of atoms. Until you open the door and ask me what I saw. I am in a superposition. I have both seen the result and not seen the result. This is the why. Infinite regression of observers. Who observes the observer? Do we need a God to look at the entire universe from the outside to make any of it real? There is a way to solve this without God or magic. Maybe the wave function never collapses. Maybe it splits. This is the one many worlds interpretation proposed by Hugh Everett. It suggests that every time a quantum event has multiple possible outcomes, all of them happen. You don't see the other outcomes because the universe splits into separate non-communicating branches. In one branch, the cat is alive. In another, it is dead. You are simply living in the branch where you opened the box and found a living cat. If this is true, reality is not a straight line. It is a tree. A fractal of infinite what-ifs. In this vast multiverse, every mistake you almost made, you did make. Every risk you didn't take, you did take. There is a version of you who won the lottery, a version of you who died in childhood, a version of you who is king. We are not unique individuals. We are a swarm, a colony of ghosts spread across the branches of infinity. This leads to the most haunting concept of all: quantum immortality. Imagine an experiment where you face a lethal quantum trigger, 50% chance of death. In the many worlds theory, the universe splits. One version of you dies. One lives, but you cannot experience death. You can only experience being. Therefore, from your subjective perspective, you will always find yourself in the branch where the gun jams, where the car misses, where the cancer goes into remission. You might watch everyone around you die, but you will be trapped in the narrow sliver of probability where you survive. Forever. So is the universe real, or is it a hallucination? Physicist John Wheeler proposed a radical idea called the participatory universe. He believed the universe is not a machine that runs by itself. He believed it is a self-excited circuit. The universe begins as a cloud of probability. It expands, it cools, it creates stars, it creates carbon, it creates biology, and finally, it creates you, an observer. By looking back at the universe, you are the mechanism that makes it real. We are not just inhabitants of the cosmos. We are its creators. The universe is asking a question, and we are the answer. We look for ghosts in haunted houses, but the ghosts are the atoms in your fingertips. Reality is not a solid stage where your life plays out. It is a fluid, interactive dream. It waits for you to wake up. It waits for you to look. Do not be afraid of the emptiness, because in a universe made of probability, nothing is impossible. You are the observer. Open your eyes.